All right, in this video, I want to take a look at adding and subtracting of Taylor series. Right? So if you've got two Taylor series for two different functions, but centered at the same place, right? So I've got centered at here's f centered at b, and here's g centered at b. The question is, can I say anything about the Taylor series of the summation of the two functions, or the difference of the two functions? And then what's the interval of convergence? Right? Now, I don't want to get into all the nitty-gritty of when this works. I'm just going to tell it to you, and when you take an analysis class someday, you'll prove it. But the idea here is that summation, each one of these things, this Taylor series is a sum of a bunch of things. And this Taylor series is a sum of a bunch of things. And if we add two sums together, we just have one big sum. We just got a whole bunch of stuff added together. And you would think that we would be able to, addition's commutative, right? You can add things in any order you want. So you could, take the first one here plus the first one there, and the second one here plus the second one there, and the third one plus the third one. And it's very intuitive to say I can do that, but it's actually not true in all cases. If your series do not converge absolutely, then this doesn't work. Okay. What do I mean by absolute convergence? These coefficients, an or bn, they might be positive or they might be negative. Right? If I were to throw an absolute value around this thing so that all of my terms are positive, so it's going to be this one plus the next one, plus the next one, plus the next one. Everything's positive. You're always adding stuff up. And it converges then that's going to be a stronger convergence than if I allow for, say, plus or minus signs. With some of them being negative, it's easier to, with some of them negative and some of them positive, you have this sort of bouncing thing that happens as you're adding stuff up. You add a positive, then you add a negative, and you add a positive, and you add a negative. Things tend to not go off to infinity as quickly, and it's easier to get convergence. Right? So it's easier to get convergence if you have the plus or minuses. It's harder if you don't. So if you get rid of all your minuses and make them plus and it still converges, that is strong convergence. That's called absolute convergence. It turns out with these Taylor series that you have an interval of convergence. The endpoints are suspect. They might converge, they might not. If they do converge, they're not going to converge absolutely. It'll be it's called a conditional convergence. But on the interior, so anything in that interval except the endpoints, you can show that you do have absolute convergence. And so you can do this addition the way I want to do it. Right? And it's just the way that you add up to infinite series centered at the same place is you just add the coefficients, right? So yeah, we'll do some examples here, and likewise you subtract by just subtracting the corresponding coefficients. You collect like terms. You're just adding polynomials. They just happen to be infinitely long. Add the two constants, add the two linear parts, add the two quadratic parts, and so on. Collect your like terms. If you're in the interval of convergence, that's fine. And it turns out that either of these, f plus g or f minus g, will converge in the overlap of the two intervals of convergence of f and g. They're both centered at the same place, so it's essentially one of them might have an interval convergent like that, and one of them might be like that, but they're centered at the same place, so whichever one's smaller, that's going to be the interval of convergence for the sum or the difference. Right? So here's an example. Let's add together two functions that we know and love here, e to the x plus 1 over 1 minus x. So here's the Taylor series, Maclaurin series for e to the x. Here's the Maclaurin series for the 1 over 1 minus x. So I'm going to add the two constants. There's my 2. I'm going to add the two linear parts. X plus x is 2x. I'm going to add the two quadratics. X squared over 2 plus x squared. That's just going to be a 1 plus a half x squared, so 1 1/2 x squared. And then the cubics, I've got 1 over 3 factorial and a 1. So 1 plus 1 over 3 factorial times x cubed, and so on. Just add the coefficients up likewise. Corresponding coefficients, add them up. Subtraction, you would do exactly the same thing, and I'm not going to give an example of it because it's so dang simple. Okay? To add and subtract the these things, as long as you're within the interval of convergence, you just add them the way you would hope you could add them, just term by term. Collect your like terms. So there you go. That's a short video.